It is a good idea to focus on a few useful notions that will make you more efficient and confident programmer. We have values and expressions. The outcome of an expression is a value. A value can be arithmetic, that is, a number, algorithmic, or logical. You already know arithmetic values. An algorithmic value is a series of characters. For example, a name or a password is an algorithmic value. We will not get into more details in regard to algorithmic values, because they are not of interest for now. For this lesson, logical values interest us the most. A logical value can be either true or false. And now, some examples. This is an arithmetic value. And this is an arithmetic expression, whose outcome is value 9. This is an arithmetic expression too. To find its outcome, we need to do the math. Parentheses have the highest priority, then multiplications and divisions, and finally, additions and subtractions. The outcome of this expression is 12 minus 2, that is, it is 10. Let us now go to logical expressions. This is an example. It is either true or false. The logical expression, 5 is greater than 3 is true, whereas 5 is equal to 3 is false. Here we see two logical expressions, one of which is the opposite of the other. The expression, not message box empty, can otherwise be rephrased as, message box is not empty. Clearly, one of these two logical expressions is true and one is false, that is, they cannot be both true or false at the same time. And now, operators. You already know arithmetic operators. They perform addition, subtraction, multiplication, and division. There are logical operators as well. We have already seen the not operator. We will spare a minute to explain their use. The not logical operator is placed in front of a logical expression and produces a new logical expression, the value of which is the opposite of the value of the initial logical expression. In simple words, the expression not 5 greater than 3 is false, because the expression 5 greater than 3 is true. In even simpler words, the expression 5 is not greater than 3 is false. If the expression it is raining is false, then the expression, not it is raining, or, phrased otherwise, it is not raining, is true. The logical operator and acts on two logical expressions and produces a new logical expression. For this new logical expression to be true, both initial logical expressions must also be true. In any other case, the new logical expression is false. For example, this logical expression is false, since the expression 5 equals 3 is false. In simple words, 5 cannot be equal to 3 and greater than 3 at the same time. This logical expression, on the other hand, is true, because 5 greater than 3 is true, and 5 smaller than 8 is also true. And finally, the OR operator. It results false if both of the initial expressions are false. Otherwise, it results true. This logical expression is true because 5 greater than 3 is true. This logical expression is also true for the same reason. Finally, this logical expression is false because both initial expressions are false, that is, 5 is not smaller than 3 and 5 is not equal to 8. And now, a few words about branches. Here you can see the two most basic block commands for implementing branches. Snap for Arduino represents logical values and arithmetic values using a different shape. It uses this shape for arithmetic values, and this shape for logical values. Observe that the branch commands have a position where we can place a logical value or expression, and not an arithmetic one. This is the most basic branch command. If a logical expression is true, then do something. We have seen such a branch in Lesson 1. This is how it works when the logical expression is true. Whatever is placed inside the block is executed. And this is how it works when the logical expression is false. Whatever is placed inside the block is not executed. This is the other basic branch command. If a logical expression is true, then do something else, do something else. Here is how it works. If the logical expression is true, the part called something will be executed and the part called something else will not be executed. If, on the other hand, the logical expression is false, the part called something will not be executed and the part called something else will be executed. And now, let us go to Snap for Arduino and see how to build arithmetic and logical expressions, starting from logical expressions. This is the logical expression we are going to build. Can you find its value before we start? To do this, recall the definitions of the logical operators. You can see here how we build this logical expression. By clicking on any expression, we can see its value. This is true. And this is false. The OR operation on these two logical expressions is performed like this. And we can see that the value of the resulting logical expression is true. By placing the NOT operator in front of this logical expression, we get a new logical expression whose value is false. And now let us build this arithmetic expression. We see that the value of this expression is 10. And this concludes lesson 2.